This is going to be a short, hopefully it's going to be short. It's going to be short video on how to get to the nth term of linear patterns and quadratic patterns, how to determine the nth term for linear and quadratic patterns. I hope you enjoy, and I hope this makes it easier for you. So there are two kind of patterns. They are linear patterns and quadratic patterns. And the linear patterns are the easier ones, of course, because there's less steps to getting to the nth term. Yeah. So there is the general term for linear patterns is the nth term is equal to a plus open bracket n minus 1 close bracket d, where this a is the value of the first term and this d is the value of the constant or consecutive difference, and d can be equal to t2 term 2 minus term 1, term 3 minus term 2, term 4 minus term 3, term 100 minus term 99. So that's why it's called a consecutive or constant difference, because it remains constant for the rest of the pattern. It doesn't change. And then there's the quadratic patterns, and the general formula is an squared plus bn plus c. This looks familiar, right? It does look familiar. You know, when you have a formula like this, you can actually use the quadratic formula, but then you can only use it when there's an O on this side and it is in standard form. But then, since the name is quadratic, you know how to get to the nth term easier sometimes. You can just use the quadratic formula, but you don't always have to. There is a constant second difference between consecutive terms. That's the difference between the linear patterns and the quadratic patterns. The linear patterns have a constant first difference, and the quadratic formula have a constant second difference. So the quadratic formula's first difference is not constant, but the second difference is constant. See, I hope you get me. So these are the steps to determining the nth term for the linear and the quadratic formula. For the linear patterns, you have to first find the constant difference. The constant difference is the second term minus the first term. You have to just it's basically the value of the second term minus the value of the first term, the value of the third term minus the value of the second term, and so on. And then you substitute the constant difference d and the value of the first term. 99% of the time they just give you the first term. It's just the first term, it's just there. And then you just have to, the one you have to calculate is the constant difference, because you have to subtract the value of the first term from the value of the second term. And these are the quadratic patterns. You have to first find the second constant difference, and then you have to use the second constant difference to find a, and then you have to find a and the first difference to find b, and you have to use a, b, and c to find c. So you get what I say when I say that the linear patterns are the more easier ones, because there's less steps, because there's a lot of steps when it comes to getting to the nth term of a quadratic pattern. That's why we're going to do it last. So we're going to find the nth term for a linear pattern. Né? That's what we're going to do. So this is like a pattern. It's 2, then 7, then 12, then 17. It's easy. You just get the constant difference. So it's 7 minus 2, as it shows there. it's 7 minus 2, it can be 12 minus 7, it can be 17 minus 12. You choose. You see how constant it is? It's 5 throughout the whole pattern. It's always going to be 5 because it is a linear pattern. And then a, the value of a is the first term, so you just get the a. The first term, the value of the first term is 2. So you substitute that 2 in here by the a, and the d is this constant difference, can be this one. It's the same thing. It's constant, does not change. It's the same. So you substitute that in, and then you say 5 times n and 5 times -1, and you get that because you multiply the positive in the bracket. This is what you get, and that's how easy it is to get to the value of the nth term for a linear pattern. And this is how hard it gets when it gets to getting to the quadratic one. This one is easy. You just have to substitute two values in, the constant difference and the value of the first term. You can even see how long this is, nah? So when it comes to quadratic patterns, you have to start from the bottom. The bottom thing is, nah, 2a, 2a, 2a. No, let me write down I'm gonna write down the formula for a quadratic. It's t n is equal to an squared plus b n plus c. It's hard drawing on this pad, but I hope you see that, as you know, you are getting this for free. So I've got colors. It's just for you. So yeah, and these colors are cool. So you have to get to the a, né? The 2a is equal to 6. So that's how you get the value of a, because 2a is equal to 6. And then when you get a, né, you substitute the a in this formula. The first difference is equal to 3a plus b. Here it is. It's 3a plus b. Then you substitute the value of the a, which you got. Substitute the value of the a, which you got here. So yeah, and then when you substitute the value of the a there, you can actually just take that side and then just get the value of b. When you get the value of b, you use this formula: a plus b plus c is equal to the first term. And then you have a already because you calculated it kwalapha, and then you have b, you calculated kwalapha, and then and then ab plus c is equal to the first term, and then you substitute the a that you got upper and the b that you got here inside this formula, and you substitute it in there, a faka, and you just take the 3 and the 2 to that side, and then you get a 1. Substitute all these values into this formula to get to the nth term, to determine the nth term. Né? I hope this made this easier for you, as I just did this kwangoku for you guys, just to start off the session, because I see that you guys are a bit shy and not talking. We're going to start doing patterns right now, because I know that you guys just started doing these patterns, but you guys are on another level. We're going to start with the basics for now, né? But then if you have other questions, feel free to ask.